Let's understand the concept of agile software development in software engineering. So, agility in software engineering is the ability to adapt the changes quickly during the software development. In the software development lifecycle, traditional models like Waterfall follow a rigid step by step approach where each phase must be completed before moving to the next. In contrast, Agile methodology allows flexibility where changes can be made at any stage without disrupting the entire process. So let's understand the concept of agility in software engineering. Agility itself, it means dealing with the changes effectively. Software engineer must be able to respond when business needs to evolve or when market condition changes. It emphasizes incremental and iterative development instead of one-shot delivery. Principle of agile software development includes customer collaboration, which means that customer can work closely with the development team. Incremental delivery. So agile software development, instead of delivering the whole product at once, it is built in small parts, tested and improved. Then flexibility in planning. Plans of agile software are not rigid. They basically adjust as a requirement evolves. Then it also consists of minimal documentation. Agile model focuses on essential work product only, and it basically avoid unnecessary paperwork. Then the last but not least, team communication. Agile software promotes direct and frequent communication among team members. The basic difference between these two is change management, process flow, delivery, documentation, and customer involvement. So, in traditional methods, it is difficult to handle changes, but in agile software development, changes are expected and they are always welcome. Talk about process flow of traditional waterfall follows the step-by-step approach, or you can say linear and sequential approach. Then agile software development, it is iterative and incremental. The documentation waterfall is kind of heavy. It consists of heavy documentation, but in agile software, minimal documentation is required. Working software is bigger than the documentation. Customer involvement, the customer is involved in only beginning and at the end. But in agile software development, the customer is involved throughout the whole process. So agility is not just a concept; it is a mindset that basically applies to different software projects. So let's imagine a scenario. Let's imagine that we are developing a mobile app for an online shopping system. So if we use traditional software development life cycle, what we will do, we will gather all the requirements at start, which will take time, which will we will design and develop with step by step with minimal flexibility. If market trend changes in mid project, we need to restart the whole process, which will eventually leads to wasting of time and money. But in agile approach, this is how we carry out this task. First of all, we will build the app into smaller parts. Basically, we iterate those parts. Then, after each part is completed, then it will be tested. It will be shown to the customer. Customer validation is required. It is mandatory in Agile software. If the market trend changes in mid project, we can adjust the next iteration without losing all the progress. This way, it can save our time, money, and resources. So now let's discuss why it is important and why some project may not suit Agile. Let's discuss one. It reduces the cost of changes. For example, if change occurs in our mid project, okay, so it will be expensive if it is done late. So the agile software development or the agile, it basically lowers the cost by handling the changes early. Then it encourages team flexibility. Agile adapts the working style of team members. It values creativity and team output. Then realistic planning. Agile software or Agile process understand that the perfect planning is important in changing market. It focuses on real-time adjustment. Continuous feedback, regular feedback from customer ensure that product remains relevant and valuable. So why some of the software or some of projects may not suit agile process? Because it's not ideal for our project. For example, the project with strict regulation like softwares or which need formal documentation or sessions that prefer stability or over flexibility. The large scale project with hundred of team members may struggle constant change. They just cannot bear the changes throughout the whole process. Banking system, it includes the banking system doesn't use agile process. So now let's talk about predictive versus adaptive approach or predictive or adaptive learning in software engineering. So in software engineering, the way project is managed depends on how well we can predict the future or how quickly we need to adapt the changes. This leads to two main approaches: predictive learning, which is plan driven approach, and adaptive learning, which is change driven approach. Predictive learning is about planning everything in advance. In this method, we try to predict all the requirement, resources, and risk before starting the development process. So, how it works in software development lifecycle? It follows a linear process, just like waterfall method. Each phase, requirement gathering, design, development, testing, deployment, is completed one by one. Changes are discouraged once a phase is complete. Works well for projects with clear and fixed requirements. For example, let's imagine that we are developing a banking software. Banking regulations are strict, so the requirements cannot change during the development. In this case, it makes sense to predict everything upfront and follow a strict sequence. Number two is adaptive learning, which is basically a change driven approach. Adaptive learning is about learning from experiences and adapting to changes as they come. This approach assumes that not all the requirements can be known in advance. How it works in a software development lifecycle. So it follows an iterative and incremental process like Agile or Scrum. The development happens in very short cycles called sprints. Feedback from each sprint is used to adjust the plan for the next sprint. Works well for the project where requirements are unclear or keep changing. For example, let's imagine that we are building the social media app. User needs and market trend keep changing, so we need to adapt the design and feature frequently. In this case, it makes sense to build and test small parts, then adjust based on feedback. Let's now the key differences of predictive and adaptive learning is the process flow. In predictive learning, the process flow is linear, step by step, but in adaptive learning, it is iterative with repeating cycles. The flexibility is low or hard to make the changes, and the flexibility is high, and changes are expected and changes are welcomed in adaptive learning. Planning. Extensive planning is carried out at the start, but in adaptive learning, minimal upfront planning, it basically evolves over the time. Risk management learning, it tries to avoid risk by predicting it. But in adaptive learning, it accepts the risk and manages the risks as they happen. The customer involvement, it is basically the customer is involved in only at beginning and at the end, just like in adaptive learning they are involved throughout the process. Documentation is heavy in predictive learning and minimal in adaptive learning. The delivery is all at once when the project is complete. In adaptive learning, it is delivered in small workable parts. So it is best for the predictive learning is best for projects with fixed well-known requirements, and adaptive learning is best for evolving or unclear requirements. So why agile? Why we use agile? Okay, so there is an image about that. Image shows that why agile method is better for the software development by pointing out the problems with the old way of doing things called the predictive model or waterfall model. In the predictive model, software is made in small steps that follows one another: requirement, design, implementation, verification, deployment. So what is the problem? The problem in this model, it works like a straight line. Once you finishes one step, you move to the next one. The- This shows the image of tree, which shows how things can go wrong. At requirement steps, the customer imagine a specific type of tree. By the time we get to deployment, the final product very different from start. So why does this happen? We can predict the requirement accurately. It won't change much, but in reality, requirements always change. Customer realize new needs or market changes. The translation will be perfect. In reality, what we plan and what we build often don't match because of miscommunication or unexpected issue. Agile is better, yeah, because Agile is different because it breaks the project into smaller parts, which is called sprint, or we build and test the small pieces at a time. We can change the plan as we go based on the overall feedback. This way, we can catch mistakes early and stay up to date with the changes. Okay, let's look up in the graph, which is on page number 8. So this graph shows the principal cost of management in software development lifecycle. It basically compares two software process, conventional and agile. Agile is better because it organizes work in smaller parts, making changes cheaper. Applying knowledge to the new situation in the real world, markets and customer needs change quickly. Agile applies techniques to adapt these changes by catching the issue early. For example, if customer changes their mind about a feature, so it is easier to adjust if you are working in small steps. Next is image on page number 9. Necessity is the mother of invention. In past, industries faced many problems like slow progress and high cost when making the software. These issues forced the industries to look for new methods. Agile was born from this need. Agile is a mindset. It is not a process. Agile is not a fix. It is a set of small steps. It is not fixed like a waterfall method. It is a way of thinking and adapting during the software development. We just need to adjust the process based on the feedback of the customer. Next, talk about that how Agile software handles unpredictability. The solution to managing unpredictability is process adaptability. This means to adapt to the changes. The process adjust when the things don't go as expected. Then incremental progress. Instead of changing everything at once, Agile adapt in small steps. Customer feedback. Frequent feedback from customer helps guide the next step. Customer feedback. Frequent feedback from customer helps guide the next steps. Operational prototypes, small working versions of the software prototypes are delivered to get feedback. Quick delivery. In Agile software development, the Agile team releases update frequently to keep pace with the change. Okay, so now let's discuss about the manifesto of Agile software development. The number one is individual and interactions. So Agile values the people over process. Motivated individuals who work together in person or through a pair programming produce better results. In a software development lifecycle, it is better to communicate within the team, which improves problem solving. Face-to-face interaction make it easier to share the ideas, fix problems, and adjust quickly. For example, in a software project, two developers sitting together to solve a coding error faster than relying on formal documentation. Number two is working software. The goal is to deliver the functional software rather than lengthy document. In software development lifecycle, every phase should focus on building and delivering something usable. Clients value software that can use, not just plans and a report. For example, delivering a working login system is better than showing a 50-page requirement document. Third step is customer collaboration. In Agile software, the customer are involved throughout the project, not just at the end or start. In software development lifecycle, phases must be flexible because requirement can change. It is impossible to gather all the requirements upfront. Continuous feedback helps make the product better. For example, in an e-commerce website development, the client might want to add new features after seeing the initial product. Number 4. Responding to the changes. Agile allows quick adjustment when requirements are being changed. Traditional software development lifecycle is rigid, but Agile software development lifecycle adapts in every cycle. Market demands or user needs can change anytime. Agile team must be flexible. For example, if a mobile app design doesn't attract users, the team can quickly redesign it instead of waiting until the end. Next is Agile software principles. Number one, customer satisfaction by early and continuous delivery of valuable software. In software development lifecycle, the goal is to keep customer happy by delivering the working software frequently rather than waiting until the end. Early delivery means feedback is received quickly and developers can adjust before it's too late. For example, in Agile, instead of delivering full project at once, developers release a smaller parts like login or search function in phase. This aligns with the increment model of software development lifecycle. Number two is welcoming changing requirements even in lost development. So in traditional models like waterfall models, changes are hard to manage after development start, but Agile accepts the requirement evolve. Changes reflect the real-world needs. Ignoring them could make final product useless. For example, if client requests a new payment method after development phase start, Agile allows developers to adjust the code instead of rejecting the change. Number three is software is delivered frequently, week rather than months. Traditional methods like waterfall methods deliver the final project at the end. I will deliver it in smaller cycles. It's basically called sprints, usually every 2 to 4 weeks. Frequently, delivery reduces risk. If something is wrong, the developer can fix it quickly. For example, in e-commerce app, the search feature could be released first, followed by the payment system, rather than getting the entire app. Number four is close daily cooperation between business people and developers. In some models, business people and developers only meet at the start and at the end. In Agile software development lifecycle, they collaborate daily. Daily cooperation means developers understand the business goals better. Misunderstanding are caught early. Number five is projects are built around motivated individuals who should be trusted. Agile believes that if our developers are trusted, they work better. Other models may focus on strict supervision. Giving the developers freedom boosts creativity and problem solving. Number six is face-to-face conversation is the best form of communication. Co-location. In software development, direct communication minimizes misunderstanding, leading to clear requirements and quick problem solving. Number seven is working software is the principal measure of the progress. The software development lifecycle emphasizes that having a functional software at each iteration, like Agile, is better progress indicator than just documentation. Number eight is sustainable development, able to maintain a constant pace. Software projects fail if they burn out resources or developers too soon. Sustainable pacing ensures consistent output. Number nine is continuous attention to technical excellence and good design. Relevance. Uh, Good design reduces technical debt, improving the software maintainability. Number 10, simplicity. The art of maximizing the amount of work done is essential. Software development lifecycle emphasizes avoiding over-engineering. Simplest solution that works is often the best. Best architecture, number 11. Best architecture requirements and design emerges from self-organizing team. Agile methodologies shows that giving autonomy to teams result is better software design. Number 12, regularly, the team reflects on how to become more effective and adjust accordingly. Reflection in software development lifecycle improves further iteration. Next, we'll talk about Agile frameworks. It consists of Scrum XP, Kanban, Crystal, TSD. Okay, so let's talk about Agile framework. The example of these frameworks include Scrum, Extreme Programming, Crystal, DSTM. These frameworks follows the mindset of Agile, but they are not the same thing. They focuses on short cycles, early feedback, and continuous improvement. Number one is Scrum framework. Scrum framework is a widely used agile methodology for software development that focuses on breaking complex projects into smaller manageable parts called sprints. It allows team to work in cycle, reviewing and adjusting after each sprint. This continuous improvement ensures that the final product meets the user needs. In Scrum, there are five important stages. Number one, requirement. Number two, analysis. Number three, design. Number four, evolution. And number five, delivery. Requirement, analysis, design, evolution, and delivery. Number two, let's talk about the team structure of Scrum. Successful Scrum team has three key roles. Number one, product owner. Number two, Scrum master, and number three, development team. So, product owner, it basically acts as voice of the customer, decide which features are important by maintaining product backlog, prioritize tasks to ensure the most valuable work is done first. Number two is Scrum Master. Ensure that team follows Scrum principle, help removing any obstacles that slow down the work. It encourages teamwork and continuous improvement. Number three is development team. It consists of developers, designers, testers, coders, etc. They are basically responsible for building and delivering the product. Works collaboratively to meet. Let's talk about Scrum artifacts. So, what are artifacts? Basically, artifacts are essential tools that project organized. So Scrum artifacts is basically they are essential tools that keep the project organized and transparent. There are three main artifacts. Number one, product backlog. Number two, sprint backlog. Number three, increment, code increment. So number one, product backlog, like a prioritized list of all features, tasks, and improvement need for the project. It is maintained by product owner and it continuously updated as a new requirement emerge. Okay. Number two is sprint backlog. It is a smaller list of tasks selected from the product backlog from for a scientific sprint. Once a sprint start, the team focuses on these tasks. Number three is increment. If working product or part of product created during the sprint, it must be functional and ready to use. So, what is a sprint basically? Like, let's just discuss about it. A sprint is a short period, usually 2 to 4 weeks, where the team focuses on completing specific tasks. At the beginning of the sprint, the team plans what they can realistically achieve. Once the sprint begins, no new work is added. At the end of the each sprint, the team holds a sprint review to showcase their work. They also had a sprint to reflect on what went well and what's needed to be improved. Now, let's just discuss about the types of Scrum meeting. Scrum uses four key meetings. It is also called as ceremonies to ensure communication and continuous improvement. Number one is sprint planning meeting. It is basically held at the start of the sprint, and the team discusses what works will be done, and tasks are selected based on the priority and team capacity. Number two, daily Scrum stand-up meeting. Basically, it is a short daily meeting, usually 15 minutes. Each team members answer three questions. What did I do yesterday? What I will do today? Are there any obstacles? It helps the team stay aligned. Number three, sprint review meeting. It basically held at the end of each sprint. The team demonstrate completed work to stakeholders. Stakeholders give feedback, which may lead to changes. Number four is sprint retrospective meeting. It is basically also held at the end of each sprint. Team reflects on the sprint by discussing what went well, what didn't go well, what can be improved. It helps in continuous improvement. So now let's discuss about what are the advantages of Scrum. Scrum offers several benefits that make it suitable for complex projects. Number one, flexibility. It can adapt to change during the environment. Number two, transparency. Daily meeting and sprint reviews keep everyone informed. Number three, continuous improvement. Regular feedback from customers. It can help improve the product. Number four is time management. Sprint breaks a large project into manageable parts, better collaboration, and it encourages teamwork and communication. Number seven. Let's now discuss about there are limitation of Scrum. Number one is required experience. It basically requires experience. Team must understand Scrum principle well. Number two, script. It basically frequent change can delay the project. It can basically time consuming if the project is delayed. Number three, role confusion. If roles are not clearly defined, conflict may arise, and which it can lead to more complex conflicts, and it will not go well for software development team and all the software. Number four is time-consuming meeting. A frequent meeting may slow down the work if it is not managed well. Okay, so in conclusion, Scrum is a powerful framework that improves how software is developed by focusing on teamwork, flexibility, and continuous improvement. Its success depends on how well the team follow its principle. While it offers many advantages such as flexibility, transparency, it also has some limitation, especially if the team lacks experience. Look into the diagram on page number 42. Look, okay, now let's talk about XP framework. It basically stands for Extreme Programming. It is agile software development methodology designed to improve software quality and responsive changing requirements. It emphasizes continuous collaboration, simplicity, and frequent release. Basically, it was proposed by Kent Beck. Core activities include planning, designing, coding, and testing. XP framework activities. In XP, planning is a collaboratively activity where developers and customer work together to determine what should be built. Number one, listening. Developer listen to the customer needs and create user stories, short description of required features. For example, I want to log in using my email and password. Number two, using stories. Written on index card by the customer, each stories include functionality and and expected output. Number three, assigning property. Customer prioritize stories based on business values. Developer estimate cost in a term of development time, measured in weeks. Grouping stories. Stories are grouped into releases. Software increment prioritization can follow these strategies. Immediate implementation. All stories develop quickly. High values first stories with higher business values. First risk first approach. Riskers story developer first to handle the uncertainties. Project velocity. After the first release, XP measures the project velocity, i.e., how many stories were implemented. This helps estimate future and delivery dates. Okay, number two is a design. Okay, in XP, design approaches emphasizes simplicity and continuous improvement. KIS principle, keep it simple principle. It basically it includes that no extra functionality is added unless it is required. For example, if user authentication works, don't add a feature of proof like feature like two-factor authentication unless explicitly it is needed due to some security reason. Yeah, obviously CRC, class responsibility collaborator. In XP, the XP uses CRC cards to identify object-oriented classes and their interactions. It basically helps developers visualizes their relationships between the classes. Prototyping for complex problem. If our design issues is a difficult, XP suggests creating an operational prototype. For example, creating a mock user interface before building the full-fledged feature. Refactoring. Continuous improvement of code without changing external behavior. For example, improving variable name or simplifying loops to improve readability. Next is coding. Coding is extreme programming goes beyond simply writing code. It involves continuous improvement and teamwork. Coding basically includes test-driven development (TDD). Before writing the actual code, developers create unit tests. This ensures that the code is focused on passing tests, increasing readability. Pair programming: two developers work on one computer, one writes code, the other reviews. What are the benefits of this? Benefits include real-time problem solving, immediate quality assurance, and faster identification of bugs. For example, when one developer writes the login logic, the other suggests the optimizing of the database query. Continuous integration: code is continuously integrated with the main project. What are the benefits? Early detection of compatibility and interface error, avoid last minute surprise. Next is a testing stage. Testing in extreme programming is not an after, though it happens throughout the development process. Uh, Frameworks are used to automate tests for repetitive execution. For example, automated login tests to ensure credential works across the browser. Regressing testing, every time the code is modified, regression testing ensure no previous functionality breaks. Customer acceptance test, it is written by customer to validate overall system behavior. It is derived from user stories. Example, ensuring the forgot password features send all the recovery email. Number 6 is conclusion. The extreme programming framework is designed for flexibility, collaboration, and continuous improvement, useful for projects where requirements evolve. Prioritize customer satisfaction through frequent releases. It encourages teamwork through the pair programming. Look into diagram on page number 47 of book that I had given in description. After extreme programming, let's understand Kanban framework. The Kanban framework is a lean methodology used to improve processes and manage workflow efficiently. Originating from Toyota industrial engineering practices, it was later adapted for software development by David Anderson. Kanban focuses on continuous improvement, changing management and service delivery, emphasizing flexibility and self-organization. Core principle of Kanban. It includes visualizing workflow, limiting work in progress, managing workflow to reduce waste, process policies, continuous improvement, and collaborative process changes. Let's understand this one by one. Number one, visualizing workflow. It uses a Kanban board divided into columns representing different type of stages, e.g. to do, doing, done. Tasks or work items like praise or bug fix are placed on card, often sticky notes, and move across the board as they progress. What stage each task is improving transparency. Number two, limiting work in progress. UI. It sets a limit on how many tasks can be progressed at once, prevents team members from being overwhelmed by encouraging completion of current work before starting new work. It reduces lead time, the time from start to finish, and improves overall quality. Managing workflow to reduce waste. Team analyze the current workflow to identify where work is stalled or inefficient. Changes are introduced to improve speed and quality by minimizing delays and removing unnecessary steps. Specific process policies. In this, team writes down the policies and criteria for tasks such as how tasks are set, what qualifies as well, bring clarity and consistency process. Continuous improvement. It introduces feedback loops to measure and monitor performance. Team track matrices like lead time or codes to see how changes impact performance. Regular improvements are made based on these data. Collaborative process changes. Decisions are made with team ensuring everyone is involved, stakeholders and developers collaborative to adapt the process as needed. It creates a sense of ownership and motivation. Now let's talk about Kanban meeting. It daily stand up meeting, working keyboard. Team reviews the board to see task status, identify missing item or stalled task, prioritizing moving high values item to completion. Leadership of the meeting rotates daily to keep it fair. Weekly retrospective meeting, the team reviews process performance data. It identifies areas needing to improvement, propose and implement changing for why Kanban. Flexibility. Number two, transparency. Number three, efficiency. Number four, collaboration. Look into diagram on page number 49. Last but not the least, DevOps. It stands for Writing, Development and Operation. DevOps was a term coined by Patrick DeBois. It is a methodology that integrates development and operation, applying Agile and Lean principle across the entire software development lifecycle. It emphasizes collaboration, automation, and continuous improvement to deliver software faster with higher quality. Key stages of DevOps workflow. Number one, continuous development. The software is dev, the key stages of DevOps workflow. Number one, continuous development (CD). Software is developed in small increments during multiple sprints. Increments are delivered to quality assurance team for testing, promote frequent release instead of large delivery. Number two, continuous testing. City uses automated testing tools to test code simultaneously at various stages, ensure that code is defect-free before moving to the next stage. It helps in catching bugs early, reducing the cost. Number three, continuous integration. New code is integrated frequently into the existing code base. Automated tests run after the integration to check for errors or conflict. It ensures seamless integration without breaking the existing system. Number four, continuous development. Once integration is successful, the software is deployed to production. Deployment may happen globally across multiple sites. It ensures a rapid and frequent release cycles, providing faster access to new features. Number five, continuous monitoring. After deployment, operation teams monitor the system in real time, track performance errors and user behaviors. It helps proactively identifying and resolving the issue before users are affected. Number six, now let's discuss on the benefits of using DevOps. A faster deployment, it speed up the release of software by automating testing and integration. Number two, improve quality. It reduces feedback loops, help catch bugs early, and maintain performance. Enhanced collaboration. It combines developers and operation staff into single cohesive team. And the greater innovation. It reduces rework and focuses on high business value tasks. It increases customer satisfaction, faster updates, and quicker response to feedback, enhance user experience, and brand loyalty. Now let's discuss why time is basically it generate revenue only after customer can access them. DevOps minimizes downtime and maximizes efficiency, giving companies a competitive edge. Organizations adopting DevOps can innovate faster, adjust to market changes, and boost market share. DevOps is more than process; it is culture of its continuous improvement, where every release aims to be better and faster and more reliable than of the last. Go and check out the diagram on page number 51.